of alternative perspectives on superposition and quantum computing, and specifically, we'll look at an interpretation of Schrodinger's equation. So just to summarize a few ideas from last week's session, if we have an n-qubit quantum computer, what that implies is that this computer can be in 2 to the power of n states simultaneously. So there's 2 to the power of n superposed states. Now this is one scheme of superposition, but what we had suggested from last week's session was that if we begin to look at the quantum realm, then we can make the case that the speed of light at the physical realm, the speed of light at the quantum realm are different. And we said that because at the physical realm we have more of a prevalence of particles, and at the quantum realm more of a prevalence of waves. And this can only be if the quanta by which matter sustains itself changes. So if h is Planck's constant, that gives us insight into this quanta of energy required for matter to stabilize itself. And where this is at some threshold level, we have particles. And if this were to be reduced, so to become a fraction of itself, then that would result in waves, since matter would not be able to sustain itself in any stable form. However, we know that h is inversely proportional to the speed of light. And so if h were to decrease, that means that c, the speed of light, has to increase. And therefore we may be able to say that the speed of light at the quantum level is greater than the speed of light at the physical level. And then if we project this trend in this direction, we may be able to reach a space where the speed of light is infinite. And what we had also suggested is that the worlds or the realities or the spaces that are created by these different speeds of light is going to be different. We already see, for example, at the physical level, because of a finite speed of light, we have the notion of past, present, and future. And plus, because we're taking the inverse of the speed of light as the lower bound, that creates a matter-based world. If we switch to this quantum realm, we have a wave-based world where there's not the existence of matter, and where past, present, and future begin to meld more easily. And if we project it out to this space where the speed of light is infinite, then what we have is a space knowing itself intimately, an intelligence knowing itself intimately in any space-time boundary. So it's a radically different kind of space, abstract space. Now, what this really implies is that it gives forth a different kind of scheme for superposition, where we may be able to say that superposition is a result of the different dynamics of functions that fundamentally exist in each of these different spaces, as opposed to the current scheme of superposition, where we have n qubits creating 2 to the n spaces, meaning that this dynamic is itself projected to create the superposed space, whereas here we have separate abstract spaces that create a superposed state. Now, to wrap our heads around this in a more concrete way, let's consider Schrodinger's equation. And Schrodinger's equation is, I'm going to write it out and then get into it, is basically a modeling of matter as a wave. And the interesting thing about this is that Richard Feynman, the well-known physicist, had commented about this equation that there is no way to derive it from anything that we know around us. It was a result of something that came out of Schrodinger's head itself. And yet it's been interpreted in a certain way. And the current interpretation is obviously very consistent with this notion of quantum mechanics, which is one of the core anchors, if you will, of quantum computing, where probability theory and statistics drives quantum weirdness and the phenomena supposedly at the quantum realm. And the interpretation of Schrodinger's equation is also as a statistical or probability function, which will tell you the probability of certain particles being at certain positions in a wave. However, there's a different way to interpret this, and that's what I want to get into, that is more consistent with this notion of superposition, this alternative notion of superposition that I'm suggesting. And so if we think about I, which is an imaginary number, it's imaginary. What that really implies is that it's likely connecting two different abstract spaces together. And we may think of this as an imaginary space, but in reality it may not be. And so I is giving us an insight that there's an interrelation between two abstract spaces. And if we think about this h over 2 pi, we already made the case that at the quantum realm, h would by definition need to become a fraction of itself for wave to exist. And this is exactly what we see here. H is becoming a fraction of itself, h over 2 pi. And so this rate of change of matter, the way that matter may recreate itself from moment to moment, is somehow fundamentally linked to another abstract space or another layer of reality, which is determined by waves. So we begin to see that there's the possibility that there may be a different abstract space that's influencing how matter itself changes over time. And if we go further into this, of course, psi is the entire wave, and we could make the case that psi is really representing this whole set of abstract spaces, if you will. And the Hamiltonian, which is currently thought of as being the result of the kinetic and potential energies of particles within a wave, or potential and kinetic energy within a wave, we can actually think of this differently as being the result of, I'm going to use the word energy, but I could also substitute by functions. So energy or functions, characteristic of the physical level, energy or functions characteristic of quantum level, and then potentially also energy or function at any other meta level, proceeding up to this space, abstract space, where the speed of light is infinite. So the Hamiltonian could be the result, it's a focusing function in a sense, of different kinds of dynamics that exist in abstract spaces, and somehow the combination of these functions is what determines how matter is going to change from moment to moment. And so this, I had referred to the need for an entirely different mathematical model. This begins to give us insight into what that mathematical model may look like, and we'll pursue that subsequently in other sessions. But the main point here is that it is possible to think about superposition in an entirely different way, leveraging off a different interpretation of Schrodinger's equation. Good morning. I'm going to begin a mini-series on alternative perspectives on superposition and quantum computing, and here I just introduced some ideas. Now let's begin with this notion in normal computing, where we have one bit that can be either representing a 0 or a 1 state, and then in quantum computing we have one qubit that, in addition to 0, 1, can also be in a superposed state of 0 and 1. And the implication of this is that suppose we have an n qubit quantum computer, that this quantum computer can simultaneously be in 2 to the power of n states, as opposed to a regular computer that would be in only one state. And this is the draw, the real attraction of the quantum computers, is that they can supposedly represent a much higher degree of information with just a smaller amount of hardware, if you will. But let's think about this in a little more detail. So when we're talking about the quantum realm, we're talking about that realm where electrons or matter or light is simultaneously in both a particle and a wave state. So let's unpack this notion of particle and wave. So if we think about a particle, then we can see that that's a property of this world in which the upper limit of light is c, the speed of light is c. So we have a certain upper limit, and in this world nothing can exceed the speed of light. So that implies we also have a lower limit, and the lower limit is such that it's the inverse of this. And this is something, this quantity 1 over c is known as Planck's constant. And we know that matter, the fact that matter can form is a result of this lower limit, because energy can express itself only in quanta, which means that there's a stability by which matter can continue to exist and not dissipate itself. But when we think about a wave, then what that implies is that this quantity here is getting drastically reduced, and it's getting reduced so that energy can then disperse itself, so matter cannot form, and therefore a wave may emerge instead. And what this implies, if this is getting reduced, this implies that we have the speed of light in this wave world, which would be much greater than c, which is the speed of light in our physical world. So now the implication of this for superposition is that we fundamentally have two different realities. So we're saying that where that wave exists, we have light which is far greater than the speed of light at the physical reality. And what that implies is that there likely has to be a different approach to really represent the superposed state. So right now there's kind of a simplicity in our assumption that we take the number of possible states from the physical world and we just extrapolate and say that that's what a superposed state represents, or the possibilities of the superposed state. But in reality, what this implies is that there's going to have to be a whole different thinking about what that superposed state is. And in subsequent explorations, we can begin to look at, one, what might be these different realities here versus here, and just a simple extrapolation. So if we have, for instance, the speed of light in this wave world greater than the speed of light p, we can extrapolate this trend and say that there's likely a place where the speed of light is infinite, and there's going to be different kinds of worlds or physical realities or realities that emanate from this. So here, for instance, we know that when we have a finite speed of light, then the finiteness itself creates both matter and it creates a sense of past, present, and future by virtue of light taking a finite amount of time to get from x to y. Now if we look at the reality that emanates from light traveling faster than the speed of light here, then we have, rather than a wave, we have, rather than matter, we have waves that exist in that kind of world, and we have a melding of past, present, and future. And if we extrapolate further in this world where we have the speed of light being infinite, we have a kind of a oneness where instantaneously everything is connected to everything else. Intelligence knows itself fully, and that reality knows anything about itself in any space and time. So we can already see that there's a whole different a set of realities that is possible, and in this exploration we would also need to re-examine fundamentals. So a different interpretation of Schrodinger's equation, different interpretation for Heisenberg's uncertainty principle, which is a cornerstone of today's thinking about quantum reality. And I would bucket all this in one category where we're rethinking about the realities that create these superposed worlds. Second, we would need an alternative mathematical model to represent, in a sense, these superposed worlds of where we have the speed of light at the physical level, speed of light in waveforms, speed of light infinite. And thirdly, what this implies is a whole different technology to access the superposed state and potentially to think about quantum computing.